Well, hello ACES people, and this is a little bit of a behind the scenes for our O2 sensor manufacturing. Now, this is a very exciting thing because, as you know, I love manufacturing and I really enjoy what we're doing here at ACES, and getting the chance to come in and show you guys behind the scenes of what goes on. Like before, you've seen our throttle body manufacturing. That's extremely epic. This is our O2 sensor manufacturing. Now, our O2 sensors are top notch as compared to a lot of the ones that I've used in the industry. So being able to come here and check out the whole process end to end. Now, there's some things I must admit we can't show because of proprietary information during the manufacturing process, but we can get to the assembly portion of it and go through that. And it's what a process. I mean, delightful people, amazing custom pieces of equipment, and we get to do a thing that I love, which is go through the quality of it all. Now, we won't be checking it because I don't have the certifications to run some of these bits of equipment here, because they are heavy-duty pieces of equipment. We're talking about electron microscopes, CT scanners, X-ray machines, amazing amount, a whole host of equipment, and the custom machinery that puts this stuff together is just spot on. I mean, me coming from a place where I used to make custom machinery and getting to watch this stuff go good, oh, it's yeah, second to none, really. So let's get out on the shop floor and walk through some of the assembly portion of this. We'll get some lovely B-roll. You'll get to hear my wonderful voice during this, and let's get into it. This is going to be fantastic, and thank you for watching this. So I hope this helps. Welcome to the next step on our journey here. So, as you know, we're in the O2 sensor manufacturer here, and this is the exciting bit. This is where all the bits and pieces come together to actually make a real sensor. So we've got a 3D printed, essentially. So it's a thick film ceramic, a planar style sensor, so nice and flat and everything. And this is where it starts its journey in going into the base lug itself. It's an M18, like a stainless material. So it gets dropped in there with this wonderful machine behind me. A bit of powder gets put in there, which is zirconium ceronium? No, zirconium ceramium. Anyways, very hard to say if you don't say it every day. Anyways, that gets stuck in there, kind of like to isolate it in position, and then an actual isolation bushing of the same material gets put into place to hold everything just perpendicular and square with where it's setting at, which that gets checked by a camera. So we do have a nice camera at the end of this machine right here, that actually takes a quick picture and says, hey, you're exactly where you need to be. If not, it fails a quality check and circles back around and gets reinstalled and checked again. So after that, it goes through to the next step. It gets a bit of pressure on top of it, and then it gets swedged together with an inductive heater. So it puts a certain amount of pressure on it and then locks it all together with a little bit of heat. It's all ceramic and stainless, so you know, we're not really hurting it by any means in that process. So we go back on down the line a little bit more, and we get into where the intermediate body itself. This is where it gets a little more exciting. There's a very, very, very special connector and a few other isolation bits that actually go together, connect, so that we can get a hold of that sensing element itself, and then be able to actually laser weld some wiring on there, just to make sure that it's going to be high temperature, it's going to be vibration free. And then we swedge everything on around that and circumferentially laser weld around the body itself to make sure nothing's going to fall apart, nothing's going to actually come loose inside of there. So it's going to be a high quality O2 sensor. So it gets down to the end of the line, and at that point it starts getting into temperature calibrations, air calibrations, and then more quality checks. We need to make sure that the heating element's working correctly, the cells 1 and 2 are working correctly, and that it's actually pulling what we calibrated, and then we're actually comparing it to another open air style test itself with some of our lambda meters to make sure that this thing is working correctly and looking good. That way, whenever it comes to getting into the ACES brand itself and goes into your car, it's perfect. So that means it can live a lot longer, be a lot better, and we don't have to worry about, oh no, my O2 sensor went bad. Not with this kind of technology. These things are very, very resilient, and they're fantastic. So anyways, let's get some B-roll of this, and we'll go through the whole process about how it's all swedged and welded together. It's very exciting for me, but thanks for hanging in there. And welcome back to the quality lab. So after we get our O2 sensor manufactured and it comes here, which is a very, very important step in the process, which is quality. I'm all about manufacturing and I love quality. So depending on what process we're checking is whether it's going to go in the micro CT scanner right here, or whether we're actually going to be zooming in on it a whole lot more close up with 100,000x microscope like what's behind me right now. Or standard issue, you got an O2 sensor, you want to check out the body and everything inside of it to make sure it's okay. We got the X-ray machine as well. So this is, you can actually see through the picture right now about how everything is lined up inside the elements, the circuitry, and all things about it. So on this side of the room right here, we got, now this is rare and hard to see, but that's an electron microscope. Now, not everybody has an electron microscope. I mean, there's another scope over here as well, but it looks like we have a sputter gun, which goes into an electron microscope, so we actually see a whole lot of the individual surface itself to really zoom in and check to see how it turned out whenever we did the thick film print for the planar sensor itself. And then with the outer body, you know, we want to run it through a CMM process. I mean, you guys know the Chroma C hexagon over here. This is a bridge style CMM, good to 3 mils, just for dimensional checking of the sensor itself. But when you're dealing with this level of manufacturing, you want to take your quality very seriously. And we do take things very seriously, so I hope that helps. So we've got through the quality lab, and here is another level of quality. Now this is a durability test. As you can see behind me here, we're in an engine dyno cell. There's acoustic tiling on the flooring, wires everywhere. When I mean O2 sensor placement, I mean O2 sensor placement. It's fantastic. So what they'll do is we'll get this 4-cylinder engine and they're gonna run the money out of it. So they're gonna run this thing and just see systematically at what distance and temperature these O2 sensors will even fail if they do. So this is more of a longevity life test verification situation here. So got a massive pipe catalytic converter, some flex pipes. This thing is actually running on pump gas, nothing crazy there. I think they run it on LP as well, but that's a whole different situation. This is a factory ECU setup, but this is just one of the many tests that happen around here. And I think we're actually next to another dyno cell as well. So I love seeing this stuff. And you should love seeing it too, because they're doing the test to make sure these things are working great and they're going to last a long time. So we're going to fire this thing up and see what it does.